And happy Tuesday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. So today we're going to be looking at section 6.1, but I have a few things I want to talk about first. Oh yes, first thing I want to talk about is on Zoom, there is a way that you can send messages that then appear on the Zoom screen. It's under the chat screen. I prefer you don't do that because during the meeting, I've got enough going on to where I probably won't even see them, and then you'll be disappointed that I don't answer you. So if you have questions, you're best off to just email me and then I'll look at them after class and get back to you if I need to on that. Let's see. Oh, I know what I want to do. I want to switch. That's not even a word. Switch screens. And let's talk about test taking strategy. Okay. Because this is something that people always somehow misunderstand. I added a sentence here to clarify it, but let's see. It says, work all problems out on scratch paper first. When you put the answer in the box in WebAssign, if it is correct, don't worry about entering your work. If you don't get the right answer, but want me to see if your process will get you partial credit, then email me your work as soon as you finish the test. Now, don't correct the work that you send me. So if you miss a problem in a test and you're hoping that maybe you had some of your work right, send me the work that led to the wrong answer. If you go back and correct it, I'm just going to delete it. I'm not even going to look at it. This is kind of like if you were taking a test in class, in a live classroom, I would look at a test question, and if it was wrong, I would go back and look, is there anything I can give you partial credit for? But it's not a case of where, well, you go back and correct your mistakes and then you get credit. That's not how that works. Any questions about that? Okay. What do we got here? Sorry about that. All right. So here on the right side, I have the syllabus. Oh, and I want to, if you haven't already, I suggest you print out the test taking policy so that you reread that before you take a test, and also the syllabus. And what I wanted to talk about on the syllabus is at the far end of the syllabus down at the bottom, it has the assignments. Today, we're going to cover section 6.1. So that's what the lecture will be on today. Now, it says it's due no later than tomorrow at 11:59 p.m. That doesn't mean that you should wait till tomorrow evening to start the assignment. You should try your best to finish the assignment today. Then if you have questions, you can email me about them tonight or during tomorrow's, we can look at them during tomorrow's Zoom meeting. That gives you time to correct them before it's absolutely due, because at 11:59 Wednesday, the assignment goes away. Don't wait until the due date to do the assignments. If you get behind, you'll stay behind, and it's not a good thing. Any questions about that? All right, over on the left side of the screen, you should see basically WebAssign, and this is the assignment for tonight. I want to point out that the parts that are in red may be different for different people. So your problems might not have the exact same numbers as somebody else's problems. So if you ask me to do a problem in class and somebody else is going, well, that's not what I have, look closely. It should be a similar problem. Also, I want to talk about how WebAssign works for those of you that haven't used it. Let's take a look at this problem number 1. It says select. So I click on this box and I'm going to choose one of these things. Let's see, it says to blank a polynomial means to express it as a product of 2 or more polynomials. And this is to factor. So I put in the answer and then I submit the answer and it says it's correct. Wonderful. Now let's go to the next problem. GCF stands for, I'm going to put the wrong answer in there. Let's see, general constant formula. Okay, submit answer. And it says it's wrong. So I have to go back and change this. Let's see, that's going to be the greatest common factor. And then I can resubmit it. And you have, I think, like 100 tries to resubmit it. So you've got lots of tries there. And over here, we can say we have what factored out the GCF. Okay. Now, other situations may require you to put in a number. For instance, find the GCF of the list of numbers. And here the answer is 6. So I put in 6, and let's see if it really is. And that says it's correct. But let's go down here. Here, find the greatest common factor of the list of terms. Well, the answer is m to the 6th power. And I can't put that in there without some extra help. So when I click on the box over here on the right side of the screen, we have what is called MathPad. And there's a whole bunch of different options: operations, functions, symbols, relation set, trig, Greek, etc. So you may have to go looking for the thing you need. Well, I want to put in m to the 6th power. So how do I do that? Well, I put in an m, and then I click on this, and then I put in the 6th power. Okay. And then let's see if that's correct. So again, for answers that require some extra kind of notation, when you click on the box, it should show up here on the MathPad. Any questions about that? All righty. Well, with that, I'm going to go back to my whiteboard screen, and we'll take a look at a bunch of examples from what we're doing today. So, oh, there is one more thing I wanted to mention. I forgot to do this in the previous class, and that is the Math Center hours. Okay. And this is online. This is a Zoom ID, as you can see here. So the Math Center, Monday through Friday, 10 a.m. to 4 p.m., Monday through Thursday, 6 to 9 p.m., using the Zoom ID that is listed there, okay? And if you don't have a chance to write it down now, you can always come back and look at the video, but and I believe they're up and running today. I'm not positive, but they probably are, if not, certainly by tomorrow. Okay, so now we're going to take a look at section 6.1. All right, first of all, it says find the GCF of each list of numbers. GCF stands for greatest common factor. So let's take the numbers 6 and 10. To find the greatest common factor of two numbers, we do the prime factorization of each of the original numbers. So 6 is 2 times 3, 10 is 2 times 5. What factor or factors are common to both 6 and 10? Well, 2 is common, and that's it. So the greatest common factor would be 2. Any questions about that example? All right, let's take a look at another example. Find the greatest, so find the greatest common factor of 28, 35, and 21. I guess I better just leave these on. 28 is 4 times 7, which is 2 times 2 times 7, or 2 squared times 7. 35 is 5 times 7, and 21 is 3 times 7. Let's see, what's common factor? 7 is a common factor, and that seems to be it. So the greatest common factor is 7. All right, let's take a look at another example. It says, find the GCF of, my writing is atrocious. The GCF of, let's see, c squared and c to the 7th power. Well, c squared is c times c, and c to the 7th power is 7 factors of c. So what do they have in common? 2 factors, or basically the lowest power of c in either different original quantity. Okay, how about this? Find the greatest common factor of 18r and 27r cubed. Well, 18 is 2 times 9, or 2 times 3 times 3, or 2 times 3 squared, and then times r. 27 is 3 times 9, or 3 times 3 times 3, or 3 cubed times r cubed. So they don't both share a factor of a 2. They do both share factors of 3. So we take the lowest power, because they both have 3 squared, they don't both have 3 cubed, and then the lowest power of the variable. So the greatest common factor is 3 squared times r, or 9r. Again, any questions on that example? Okay, let's see here. Find the greatest common factor of 15 c squared d to the 4th, 10 c squared d, and 40 c cubed d cubed. So let's see, 15 is 3 times 5. 10 is 2 times 5. And 40 is 2 times 2 times 2 times 5, or 2 cubed times 5. And then c cubed d cubed. So looking at the number parts of each one, let's see. They don't all have any 2s. This one, the first one doesn't. They don't all have 3s, but they all have what? A single 5, and then c squared, and then d. So the greatest common factor is 5 c squared d. Any questions on that? All righty. Find the greatest common factor of 2 times the quantity y minus 1 and 5 times the quantity y minus 1. Well, they don't both have a 2 and they don't both have a 5, but they do both have a factor of y minus 1. Okay. Now, let's take a look at this. It says factor out the GCF. So 18x plus 24. So 18 is, let's see, that's 3 times 2, or what? 2 times 3 squared times x. And then what? 8 times 3, 2 times 2 times 2 times 3. So 2 times 3 squared times x plus 2 cubed times 3. All right. So what have I done? I've got the prime factorization of each one. So they both have 1, 2. They both have 1, 3. They don't both have an x. So let's see. We've got what? 2 times 3, or 6. So 6 is the greatest common factor, but the directions don't say find the greatest common factor. They say factor out the greatest common factor. So if I take a 6 out of this, what do I have left? 3x. If I take a 6 out of that, what do I have left? Plus 4. And let's look at this a slightly different way. Maybe it'll be more useful. If we write it like this, we see that they have a 2 in common and a 3 in common. So that's where we get the 6. But what's left over? 3x plus 4. Okay. Any questions about that?
Yes, I do have a question on that factor out. Okay, so my question is, you said that I have to use the factor that goes on both questions, correct?
Right, that's why we say it's common.
Mm-hmm. Yes. So to get the The second, what I got lost a bit, it was on the third example that you just gave us.
So this one right here or a previous one?
No, 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 the one we're working on it.
Okay, okay. So where
But
did I lose you?
right there by where it's 2 times 3 times 3 times x.
So here? Right here?
Yes, that's where I got lost a bit.
Okay. In fact, let's do this. Okay. So this is 2 times 3 times 3 times x. 8 is 2 times 2 times 2. So this is 2 times 2 times 2 times 3. So what I have here is the prime factorization of the first and second terms. Are you okay with that?
Yes.
All right. So I want to know what is common. What is a common factor of both of them? Well,
That would be 6.
they both have a 2 in common and they both have a 3 in common. So that would be 2 times 3 or 6. But what's left over is 3x plus 4 inside the parentheses. So I'm taking this and factoring a 6 out, and then this is what's left over. Is that okay? All righty. Now, I want to go back and do this problem again. Some of you might look at that and say, oh, well, both of them are even, so I could take a 2 out. Now, while this is a true statement, it is equivalent to that. We didn't take out the greatest common factor because I could still take a 3 out of both of those. So the idea is to take out the greatest common factor, the greatest amount that you can, not just any factor, but the greatest. Okay. All right. How about this one? 15s minus 35. What's the greatest common factor of 15 and 35? It would be a 5. But what about the s? They don't both share an s, so s is not common, so I can't take it out. Well, 15s divided by 5 is 3s, and 35 divided by 5 is 7. Are you okay with what I did there?
Yes.
All righty. How about this problem? 27a squared minus 9a plus 9. Well, all three of them share a 9, but not all three of them share any a's. So 9 is all I can take out. So I have 3a squared minus a plus 1. Now, sometimes people forget to put this 1 there because they think, well, I've already got the 9, so I don't need anything. But you do need it because you need to be able to get back to here by distributing the 9. So if you don't have that plus 1, you won't be able to get back there. Okay, so be sure to have that 1 there if it's needed. Okay, how about this one? Negative x minus 2y. The directions here say, excuse me, factor out negative 1 from each polynomial. So if we take out a negative 1, that would change the sign of each term that's now inside the parentheses. We okay with that? You might ask, why do that? Well, down the road a little bit, we'll learn that when you're factoring, if your first term is negative, it's a good idea to factor a negative 1 out of everything. It just makes it easier to factor what's left. Okay. All right, now take a look at this example. y times x plus 2 plus 3 times x plus 2. It
Mr.
says,
Mayo,
yes,
I have to go. I need to go pick up my son. It's early release this week. So I just
Sure.
wanted to let you know so I didn't just disappear.
okay, thanks. I won't send the police looking for you.
All right. Thank you.
Okay, you bet. Take care. All right. So the greatest common factor of these two expressions is the quantity that's in parentheses. So we'll take that out. And what's left is y plus 3. So here we have this final answer. Any questions about what I did there? Took out the greatest common factor, and then I had the leftovers as my second factor. Okay, let's take a look at another one of those. M times the quantity P minus Q minus 5 times the quantity P minus Q. So I'm going to take out the greatest common factor, which is P minus Q, and my leftovers are M minus 5. Any questions about that? All right. This leads us to something called factoring by grouping. So factor by grouping. And here's what we're going to do. We're going to end up, we're going to initially have 4 terms. Now, if we look across all 4 terms, the only thing that's common to all 4 of them is just a 1. What we're going to do is we're going to break it up into 2 groups of 2. The greatest common factor of the first 2 terms is a 2, and the leftovers are x plus y. Everybody okay so far? The greatest common factor of the second 2 terms is an a, and again we're left with an x plus y. But we need to have a sign right here, and that sign in this case would be a plus sign. Okay, now this problem looks like the previous 2 problems. We'll take out the greatest common factor and we'll have the leftovers. So this is factoring by grouping of that. Let's check our work. How would we do that? Well, we'd FOIL these back together and we get 2x plus ax plus 2y plus ay. Let's see, there's that term and that term and that term and that term, so it checks. All right, let's take a look at another example. 12ab minus 4ac plus 3db minus dc. As we look across all 4 terms, the only thing common to all of them is a 1. So let's factor it by grouping groups of 2. The greatest common factor of the first 2 terms is 4a. Leftovers is 3b minus c. The greatest common factor of the next 2 terms is d. The leftovers are 3b minus c. And between the 2, I need a plus sign for this to work. Well, now the greatest common factor of these 2 terms is 3b minus c, and then times 4a plus d. So here we have our final product. Any questions there? Okay, let's take a look at another example. 6a cubed minus a squared plus 18a minus 3. Well, let's see. Again, there's no greatest common factor of all four terms. So we'll split it up into two groups of 2. The greatest common factor of the first two terms is a squared. The leftovers is 6a minus 1. Don't forget I need that 1 to get back there. The greatest common factor of the next two terms is a 3, and leftovers are 6a minus 1, and I need to have a plus sign out there. So now I get 6a minus 1 times a squared plus 3. Any questions about that example? All right, let's take a look at this one. It says tx plus tz minus x minus z. Well, the greatest common factor of all four terms is just a 1. So again, we'll use grouping. The greatest common factor of the first two terms is t, and the leftovers are x plus z. Well, now the greatest common factor of the next two terms, well, it could be, we could take a 1 out, or we could factor out a -1. But let's go back and let's look at a pattern that we've got going here. Okay. Notice here, when we first started looking at this kind of situation, the two quantities in parentheses match so that we can take them out as the greatest common factor and then have the leftovers. Here, the two quantities in parentheses match so that we can take it out. Here, the two quantities match so that we can take it out. Here, the two quantities match so that we can take it out. And again, they match so we can take it out. So what has to happen here for this to work is these have to match. So rather than looking up here and saying, well, is it going to be a +1 or a -1 outside? I looked over here and said, oh, I need to have these two quantities match. Now, how do I get that to happen? By taking out a -1. Because if I took out a +1, I'd get +x plus z, and that's not what I need. I need -x minus z. Okay. So now in the next step, I've got x plus z times t minus 1. Any questions there? Okay, let's take a look at another example. 9p minus 9q minus mp plus mq. Well, the greatest common factor of all four terms is just a 1. So factoring by grouping, the greatest common factor of the first two terms is a 9, and I have a p minus q left over. So what am I going to need there? I'm going to need a p minus q. Don't look up here, look over here and just clone that thing, okay? Make it match, and then come back and see, can we make that true? We'd have to take out a minus m, not a plus m. So I'd get minus mp plus mq, okay? So don't look up, look over and match them. Okay, now p minus q comes out, and 9 minus m are the leftovers that go in the second parentheses. Okay, let's take a look at another example. 5m cubed plus 6 plus 5m squared plus 6m. Well, there is no greatest common factor except a 1. So if I split it up to use grouping, the greatest common factor of the first two terms is just a 1. So I get what? 1 times 5m cubed plus 6. That's not going to work. So what do I need to do here? Well, what I need to do is, to start with, let's put our polynomial in standard form or descending powers of the variable, okay? Then let's come back and use factoring by grouping. We'll take out a 5m squared and have a m plus 1. So over here, m plus 1, and on the outside a plus 6. So then I get m plus 1, 5m squared plus 6. You following that okay? Any questions there? Okay, well, I'll assume that you're doing fine. Let's take a look at another example. Let's see here. This is h cubed minus 8 plus h minus 8h squared. So the first thing I'm going to do is put this in descending powers in terms of the variable h. There's no greatest common factor other than a 1, so I'll break it apart into two sets of two factors, or two terms, excuse me. The greatest common factor of the first two terms is h squared, so I have an h minus 8 left over. So over here, I'm going to want an h minus 8 left over. And out here, now I could just put a plus sign out there and it would be correct. But if we do that, then at this point, it might be confusing what needs to go there. There needs to be a 1 here. So I strongly suggest you write the 1 there to remind you that you need it in the next step. Okay. Let's see here. Ax cubed minus 2ax squared plus 5ax minus 10a. So here we have a polynomial with 4 terms. Up until now, all these 4-term polynomials, there was never a greatest common factor to take out first. But here there is. We can take out an a. So we get a times the quantity x cubed minus 2x squared plus 5x minus 10. Then the quantity in parentheses will factor by grouping. So we have an a, and I'm going to switch from parentheses to brackets here. You'll see why in a minute. The greatest common factor of this would be x squared. So I've got x minus 2. Notice I'm going to use parentheses inside. So that way, that's why I switched to brackets on the outside. And then over here, x minus 2 and a plus 5 outside. Okay. So that was factoring by grouping there. And then a times x minus 2 times x squared plus 5. Again, that comes out and that comes out. So there's your final answer. Any questions about that?
Yeah, in the parentheses, before you went to the brackets, how do you get the x2 from the x3?
How did I get this from here?
Mm-hmm.
Okay, so if I've got x cubed minus 2x squared, and I want to take out the greatest common factor, this is like x times x times x minus 2 times x times x. So there's 2 factors of x, or x squared, that are common to both. I can't take x cubed out of that one. There aren't enough x's there. Are you seeing that, Abel?
Yes.
So then your leftovers. So that's how I got from here to there.
Okay, got it.
All righty. Let's see here. How about this one? H squared times the quantity 14 plus r plus 5 times the quantity 14 plus r. And it just says factor. Well, it looks like this has already started the process of factoring by grouping. We've got 14 plus r taken out of both, and h squared plus 5, what's left over. So there's our final answer. Okay. If we have something like this, 22a cubed minus 33a squared, we can take out an 11a squared. We can take 11 out of the 22 and the 33, and a squared out of the a cubed and the a squared. So what's left over is a 2a minus 3. Because if I multiply that back together, I get 22a cubed minus 33a squared. And I can't take anything more out of the 2a minus 3. So that's how I know that that's my final answer. Let's see here. How about this one? Let's see. We've got negative 25 x to the 5th, y to the 7th, plus 75 x cubed y squared. So I'm going to go ahead and factor out a negative. And let's see, I can take a 5 out of 25 and out of 75. I can take out x cubed out of x to the 5th and x cubed. And I can take out a y squared out of y to the 7th, y squared, and a y squared. So what do I have left over here? 5x squared y to the 5th minus 15, just minus 15. Oh, but you know what? I missed something, didn't I? Because look, I can take a 5 out of that. So in fact, I can take what out of those? I could take out a minus 25, can't I? Yeah. So let's go back here and let's redo this. So this would be minus 25 x cubed y squared. So again, how did I know I'd missed something? Because what was left over in parentheses had a common factor that I should have taken out that I missed. So now I've got what? X squared y to the 5th minus 3. Okay, that would give me minus 25 x to the 5th y to the 7th. Good. Minus 75 or plus 75 x cubed y squared. And there's nothing common to those. So there's my final answer. All righty. And what about this one? Oops, it's minus 2x plus 5. All we could do here would be to factor out a negative 1. And we could write it like that. Or we can write it like that because with a negative out in front, it's like there's an implied 1, so it's still negative 1. Oh, something about WebAssign. I'm not sure why, but it doesn't like ones where you don't need them, okay? So let's say the answer to a problem is X. Oops, it's X. And you write 1X, it's going to mark it wrong. And it isn't wrong, but WebAssign doesn't, it confuses WebAssign. It says, well, we don't need to put anything there, so don't. Okay, so just get used to that idea. All right, well, that's all I've got for you today. So tonight's assignment is section 6.1. I'll be back at 1:15 this afternoon with an office hour. And so I'm going to go ahead and stop the recording.